Hi everyone. Welcome to today's lesson on calculating the surface area of prisms. For today's lesson, you're going to want to have your math notebook or some paper, a pencil or a pen, and a calculator. Please pause the video at this time if you need to go gather up those materials, and you can resume once you're ready. Just so we're all clear, when we're calculating surface area of a 3D shape, the surface area really is the total area of all the faces or surfaces of that three-dimensional shape. Now, today we're going to be focusing on prisms. So let's just make sure we're all on the same page as to what a prism is. A prism is a three-dimensional shape which has identical bases that are parallel to one another and are connected by rectangular faces. So you can see I have put a couple examples on this slide of prisms. The first one here on the left is a rectangular prism. Okay, so I can think about the bases as the top and the bottom, or technically I guess I could think about it as the front or the back or the left and the right side. Okay, all of the faces of a rectangular prism are rectangles. The bases are going to be congruent to one another, so they're the same size and shape, and they are connected by rectangles. So in this rectangular prism, the front and the back rectangles are the same exact, they're identical, they're congruent, same size and shape, and they are connected by other rectangles, which would be the top, the bottom, the left, and the right side. On the right over here, I have shown a triangular prism. In this prism, the bases are triangular, hence the name, and that means that in this prism, the front and the back are identical triangles. They are congruent to one another, same size and shape. Those two triangles are then connected by three rectangles that are not necessarily all the same size rectangle. So we'll take a more specific look at that in just a minute. All right, ladies and gentlemen, we're going to take a look at an example. We're going to be calculating the surface area of this rectangular prism. You can see I've also shown this prism if we took it and cut it along its edges and made it flat. That makes it really easy to see that we're really calculating the surface area of 1, 2, 3, 4, 5, 6 separate rectangles. Okay, so sometimes it is easier to label our work. I'm going to say we have 6 separate rectangles, but we already talked about the fact that some of these rectangles are the same size as each other. So for example, the top and the bottom of this rectangular prism are going to be the same size and shape. So I'm just going to trace the top and the bottom here in green. And I can see that the top and the bottom, they're rectangles, which I find the area of a rectangle by doing length times width. And the length and width of that set of rectangles is 5 and 7. And there are 2 of them. So the surface area of the top and the bottom are going to be 70 square centimeters. Okay, now we also are going to have rectangles at the front and the back that are matching to each other. Now I'm just going to trace those in this fuchsia color. Okay, so the front and the back are also rectangles, so I'm still going to continue to use length times width. And I can see that the length, and this time the width is really how tall the rectangle is. So that's going to be 7 times 3. And then we're going to double it because we have a front and a back. So if we add the front and the back, we'll be adding 42 square centimeters. And then we also have rectangles at the left and right sides. I'm going to trace those in blue. Tracing is not necessary, but sometimes if you're a visual learner, it does help you visualize the different sides. So it's a strategy that can be used if it's helpful for you and can be ignored if you don't need it. Again, the left and right sides are a rectangle, so we're going to continue using area of a rectangle formula, length times width. I'm going to say my length is 5 centimeters, and my width is again the height this time, so 3 centimeters. That's going to give me 15, and there are 2 of them, which means that the left and right side add another 30 square centimeters. Okay, our last step then is going to be to add up all of those sides. So I'm going to say 70 plus 42 plus 30, and that is equal to 142 square centimeters. Okay, now if I use my net, a net is that flattened out version. I can look at the dimensions of each rectangle separately. So up on the top, I have 3 by, if I look down here, this is 7, which means this is 7, this is 7. So 3 times 7, 21 for that rectangle. Here I have 5 times 7, or 35. I have another 3 times 7, 21. 3 times 5, which is going to give me 15. 7 times 5, which gives me 35. And 3 times 5, which gives me 15. Again, if I add each of those separately using this strategy, surface area will still be 142 square centimeters. So 2 separate strategies depending on the way that your brain likes to process this. Okay, ladies and gentlemen, the next prism we're going to take a look at is a triangular prism. Just a quick reminder, a triangular prism is going to have 2 identical triangles. In this case, I'm going to say at the left and right sides, although some of you may view that as the front and the back. Either way is fine. We just need to know that we have 2 identical triangles. And the formula to find a triangle is base times height divided by 2. Okay, now remember that base and height are the 2 dimensions that get together and form a right angle. So in the triangle here, it's going to be the height of the triangle and the bottom side, bottom edge. And I have 2 of these, so I'm just going to put a times 2 in front. So I remember to double it to cover both the front and the back triangles. So for these 2 triangles, I'm going to do 2 for the doubling, times 10 times 12 are my base and height here, divided by 2. 10 times 12 is 120 divided by 2. 120 divided by 2 is 60, and I'm going to double it so I have the 2 triangles. And the surface area of the triangles is 120 inches. Now you can see the same triangular prism to the right, just in that flattened out net version. And that makes it really easy to see that we do have the 2 triangles. Here are my base and height, and those triangles are identical to each other. Okay, so we can also see that those triangles are connected by 3 rectangles. Okay, so I'm going to label this area of a rectangle. I'm just using my symbols here instead of writing out the word rectangle, and I'm going to put 1 in there. So this is going to be rectangle number 1. I find the area of a rectangle using the length times width formula, and in this case my length and width are 18 and 13. Now 18 times 13 is equal to 234. I am not doubling this. This is just 1 rectangle, and I will calculate the area of each rectangle separately. So, area of the second rectangle, this is the one in the middle, And the length and width here are 10 and 18. And that means the area of that rectangle in the middle is equal to 180 inches squared. Oh, let's not forget my labels. And my third rectangle is this bottom one here. And that is also going to be the same size as the first one, 18 times 13, which is 234 square inches. Okay, now for my total surface area, I'm going to add together all of the individual sides that I calculated. So my surface area is going to be equal to 120 plus 234 plus 180 plus another 234, which gives me a total surface area of 768 square inches. Okay, I think you guys have enough to go on, and I would love to have you check your teacher's homework page for what your assignment is for today. Have a great day, everybody.